Welcome to the XtextCasts. Today I would like to talk about Xtend control flow. Of course, the Xtend has almost all Java control flow features like if or while, but it brings two new powerful control flow features I would like to present here. For the demonstration purposes, I prepared a little example. And here I have a simple data transport object. This is a rectangle with a width and height attributes. I have a pretty printer, and this is a goal today, to write such pretty printer that calculates a string representation of the object passed, and this should support standard types, custom types, user-defined types, and also null and unknown objects. And this is probably the common implementation in Java, where we use a series of if blocks with instance of checks, then the type casting, and then the calculation of the result string. And here actually we have one more if to catch the situation that we have a square. And we will see that we can improve this pattern with Xtend in two different ways, using two new Xtend control flow features. And here's my test class. I construct an array of some objects. Here's an integer objects, rectangle, square, and unknown objects, unknown to this pretty printer object, string builder, and a null. And then I just output all those objects processed with the pretty printer. And we can see the result. This is a formatted integer, the rectangle, the square, object, and the null. Let's create our first Xtend class. And first we have to import the Xtend runtime library. And then I'm going to copy the Java implementation and just paste it here. Now the idea is to write a method for each if block, so that we expect the parameter, the type, we check in this if block. So we don't have to check and don't have to cast. And this definitely simplifies the coding. And I proceed for the rectangle. And here we can further improve our coding by using it as a name for the parameter. And this allows us to just omit the call to the mention of the parameter at all. So we can just say width, and this going to call the getter of the rectangle. Very cool. And with those improvements, our coding becomes much more clear and readable. And I just leave alone this null for a time being and proceed with the object. So we expect here the object. And now let's test it. And what do you think? Of course, that's not going to work. And this is because this going to call always this object method, method expecting object as a class, as a parameter, because this decision with method, which method should be called, is a compile time decision, and at the compile time we know nothing about this object parameter, of course. And we have actually no chance to overcome this problem in Java, but in the Xtend we have a dispatch keyword that activates the runtime decision about which method to call. And by just simply adding this keyword, we alter the behavior totally. So this actually works. We get an exception about this now that we take care of, but the rest, rectangle, square, object, and integer work. So let's implement the method for the now, and in this case we have to expect a void parameter, and then we just return our null string. And now we are done. We have complete implementation with much better coding. In our second Xtend implementation we are going to use switch, and the Xtend switch is much more powerful compared with the Java switch. Let's create our second Xtend class. And I'm going to copy the first Xtend implementation to begin with. And we don't need the dispatch keyword here, and we go back to our object parameter. And within Xtend switch we can simply write the type then the colon to perform the instance of check. And within this expression the object gets automatically casted to this type we checked. So this is all we need. Let's proceed with the rectangle, and I spent a few more lines here. I cover this case first. We need just object prefix here to access width and height attributes. And as you can see, object get cast to the rectangle automatically here. In order to detect squares, we need to perform a further check, and we can do it with a case keyword and then pass the condition. Within this condition, this automatic casting is already in place, so we can take advantage of it. And here the order of this statement is important, since switch checks each statement here from the top to the bottom, and the first statement matched get evaluated and returned to the result of the switch statement. So we have to write more specific conditions first and more generic conditions after it. Then we can perform our null check by simply writing case null. We don't have to write here something like object equals null, because if we pass here a non-boolean condition, then it gets compared with an object automatically. And the last but not least, we can write this as an object guard, but I think it would be more convenient to use the default keyword. And we are done here. So let's test it. And okay, I just copied the line here for the rectangle. We need this line for the squares. So another try, and that looks good. Integer, rectangle, square, object, null. Now let's compare these two implementations. The first implementation uses multiple methods with a dispatch keyword, and the second implementation uses the switch. And in this particular case, where we have only one line for each condition, I would stick with the switch variant. It is a much less code and more readable code. But if we would have more logic to put in each method, I would choose this dispatch variant. Thank you for watching XtextCasts. Go to the XtextCasts.org to get show notes, discussions and more episodes.